In this video, we will discuss the basic rules of algebra. Some of these should be reviewed to you, some of them will seem like common sense, and some of them may be new. So the basic rules of algebra. Let A, B, and C be real numbers, variables, or algebraic expressions. So that's telling us that all of these properties are going to work for real numbers, variables, or algebraic expressions. The commutative property of addition. This states that A plus B equals B plus A. This is that statement where we get the concept that it doesn't matter what order we add in, we'll always end up with the same sum. Similarly, we have the commutative property of multiplication. This again gives us that order doesn't matter idea. So when we multiply two values together, A times B, it will give us the same product as if we took B times A. Then we have the associative property of addition. This is the property that involves grouping. So it says that if we're adding three things together, it doesn't matter which two we add together first, we will still end up with the same sum. Similarly, we have the associative property of multiplication. When we're multiplying three values together, the order in which we multiply them does not matter. Then we have the distributive property. This is one that we use rather frequently and you should be very familiar with. So with that distributive property, we get the idea that A can be multiplied through to those parentheses. And when we do that, it multiplies to each term in those parentheses. So A times the quantity B plus C becomes AB plus AC. Additive identity property. This says that when we add 0 to any value, we obtain the value that we started with. The multiplicative identity property says that when we multiply anything by 1, we get whatever we multiplied by 1. The additive inverse property. So A plus negative A equals 0. Here we're looking for the two values that when we add them together, they give us 0. With the multiplicative inverse property, we're looking for the reciprocal of our value. So that when we multiply our two values together, our first value and its reciprocal, which is what we get when we flip that fraction, we obtain a value of 1. And of course, because here we're dealing with a fraction, A cannot be equal to 0. Properties of negation. Let A and B be real numbers, variables, or algebraic expressions. So again, we have properties that are going to work for real numbers, variables, or algebraic expressions. These are some of the properties that we've used many times, and they kind of feel like common sense, but we actually can formally state them. So number 1, negative 1 times A is equal to negative A. Number 2, negative the quantity negative A is equal to A. So that's kind of like saying the opposite of a negative is positive. Number 3, negative A times a positive B is equal to negative times the quantity AB is also equal to A times negative B. So it doesn't matter where our negative value is, it will always be the same value. Number 4, negative a times negative b is equal to ab. This is that concept before that we've had where a negative times a negative is positive. And number 5, this is saying that we can also distribute negative values. So negative times the quantity a plus b is going to be equal to negative a plus negative b. Properties of equality. Let a, b, and c be real numbers, variables, or algebraic expressions. Number 1, if a equals b, then a plus c equals b plus c. So this is saying that if we add the same thing to both sides of an equation, then the equation will still be true. Number 2, if a equals b, then ac equals bc. So where number 1 we were adding the same thing to both sides, now we're multiplying the entire equation, both sides of it, by the same thing, and it's still going to be true. Number 3, if a plus c equals b plus c, then a is equal to b. This is kind of going a little bit backwards of number 1. And finally, number 4, if ac equals bc, and c is not equal to 0, then a equals b. Properties of 0. Again, these properties work for real numbers, variables, and expressions. Number 1, a plus 0 equals a, and a minus 0 equals a. So we can add or subtract 0 from any value, and it will give us back the value that we started with in the first place. Number 2, a times 0 equals 0. This is that property that we learned in elementary school where anything times 0 is 0. Number 3, 0 divided by a equals 0. So this is saying if we have 0 objects, we can't divide them into any number of groups because there's nothing to divide. Number 4, a divided by 0 is undefined. So we cannot divide by 0. Finally, number 5. This is something that we use quite a bit, especially in Algebra 2 and in the more advanced algebras. The 0 factor property. So this is saying if a times b equals 0. So if we multiply two values together and we get an answer of 0, then either a had to be equal to 0 or b had to be equal to 0. And sometimes both might be equal to 0. One area where we definitely use this a lot is solving quadratic equations. Properties and operations of fractions. Okay, and the statement above says we're going to let a, b, c, and d be real numbers, variables, or algebraic expressions. However, here we have the quantifier that b and d are not allowed to be 0 for anything. And if you look, b and d are always for all 7 of our properties in the denominator, and denominators are never allowed to be 0. So number 1, equivalent fractions. A over b is equal to c over d if and only if AD equals BC. Okay, this is that cross multiplication. Number 2, rules of signs. This is discussing your placement of negative symbols. So if we put the negative out in front of our fraction, it's the same as having a negative over a positive or a positive over a negative. And if we have a negative over a negative, of course our fraction becomes positive. Number 3, we can generate equivalent fractions by multiplying the numerator and the denominator by the same value. And of course, we don't want that value to be 0 because that would give us 0 in a denominator and make it undefined. Number 4, in order to add or subtract fractions with like denominators, we simply keep the denominator and add or subtract the numerators. If we need to add or subtract with unlike denominators, we need to obtain a common denominator, and we do that by multiplying the two denominators together. And sometimes there are more efficient ways to do that, but this is definitely one way that would always work. You may just have some extra simplifying to do in the end. Remember that when we multiply a over b times d to get the bd in the denominator, we actually have to multiply by d over d, which is a form of 1. When we multiply fractions, as shown in number 6, we simply multiply straight across the numerator and straight across the denominator, simplifying at the end if necessary. And when we divide fractions, we flip the second fraction and multiply, as you can see here. So let's talk for a minute about some properties and operations of fractions. So we're going to generate a fraction that is equivalent to x over 5. The way we can do that is by multiplying by 3 over 3. And we can do that because 3 over 3 is a form of 1. So we're changing what this fraction looks like, but we're not changing what it means. And when we simplify this, we get to 3x over 15. Normally we would want to simplify that, however here we're generating equivalent fractions, so that is not a necessary step for us to take. An example of dividing fractions. So let's say we had something that looked like 7 over x divided by 3/2. We would change this to be 7 over x times 2/3. And when we now perform our multiplication, we end up with 14 over 3x. And finally, we have adding fractions with unlike denominators. So here we have x over 3 plus 2x over 5. Notice that in order to have a common denominator, we need to multiply our first fraction by a factor of 5 over 5. So we'll take 5 over 5. And then our second fraction, we need to multiply by 3 over 3. This is going to give us 5x plus 6x over 15. And when we simplify this, we will have 11x over 15.